Welcome to Office Mechanics. On today's show, if you've ever wondered how network connectivity to Office 365 works, we'll give you an insider's look at data center coverage. We'll demystify how you can optimize network performance by planning connectivity to Office 365. And keep watching as we share top troubleshooting tips to help you and your users get the best performance with Office 365. My networking expert, Paul Andrew. Welcome.
Great to be here. Why don't we start by talking about some of the scale of the service?
Right, so if you think about it, it's not a trivial task to keep Office 365 up and running with a constant level of networking coverage and performance. Office 365 is a global service. It's built for customers all over the world, and we're currently available in 140 different markets and growing.
And in each of those markets is covered by Microsoft data centers in that region. So, for example, if you are a customer in the UK, you'd be served out of the Europe region, which has data centers in Dublin and in Amsterdam.
Right, and so that answers the questions about data center coverage, but how about the network itself?
Yeah, Microsoft actually has one of the largest networks in the world, even when compared to telecommunications companies and internet companies. And it's used for connections between Microsoft data centers and also for more than 50 interconnections to the public internet, which are in 23 countries. We actually have either physical or logical routing agreements with over 1,500 network operators and ISPs. We also make use of content delivery networks and edge nodes to further improve performance.
So that's a lot of connectivity that we have that we're managing, but how do we actually optimize that connectivity for customers using Office 365?
Right, so the important thing is routing packets over that network from the customer network. And we work with different ISPs and network operators to make sure that that routing works really well. We had a recent case where a customer in the UK was actually routing packets over the Atlantic Ocean 3 times before connecting to our US data centers. And so we were able to work with the ISP, improve their routing, and avoid that.
So it sounds like we've got a lot of infrastructure, a lot of great reports, but how do I think about connecting to the service and to the internet as a user of Office 365?
Right, we often think about connecting to the internet as if it was connecting from your PC to the cloud or connecting to the Wi-Fi access points in the hallway. But of course that's not true. There is a lot of infrastructure, a lot of networking equipment out there. So in reality, the internet is made up mostly of submarine cables because as the internet has grown, it's much easier to add submarine cables off the back of a ship than it is to dig more trenches throughout the globe. There are submarine cables around a lot of different continents, around Africa, India, and APAC, which is largely what makes up the internet.
So it sounds like a lot of things are outside of our controls as admins for Office 365, but I bet a lot of people are wondering what they can do as admins to really optimize performance of Office 365.
Great, so there's a ton of things you can do as an admin. To start, when using cloud services like Office 365, your internet connection becomes much more important than before. The first thing you want to do is a capacity planning exercise. You need to know about how much new internet traffic is going to be generated by using Office 365 and how that compares with the available bandwidth that you have.
And we have tools for a lot of the Office 365 workloads to calculate capacity, so why don't you show us one of those?
Great, so let's look at the tool for OneDrive for Business.
Okay.
So this is an Excel spreadsheet, and on this first page, you can see we're setting up some details about the environment that you have. We're setting up a user profile for light users and a user profile for standard users. And you have to plug in the average file size, the average new files that the users generate per day, the average number of files they edit, and the number of files that are pre-existing for each of these profiles.
And we plug in a few default estimates so you can get started very quickly.
Yep, and once you've set those, we can go over to this client mix page where you can set up for each site that you have in each location, specifying the time zone and the type of users that you have there, how many Windows clients you have, Mac clients, and mobile clients. So if I go ahead and update one of these numbers, you can see that my calculations for network bandwidth are updated, and this shows me an estimate of how much bandwidth I'll need. It also shows me the number of TCP connections, and that's important for configuring your perimeter network devices.
And you can even look at things like traffic by time of day with this too, right?
Yeah, so let's take a look. If we scroll down, because we've filled in those time zones for all those different offices, it's going to estimate how much bandwidth users are using at different times of the day, so that you can see how your network bandwidth changes.
And these are just estimates, so something that you can do even more in terms of more testing is really look at the actual bandwidth being consumed by users and monitor that traffic as a baseline, right?
Yeah, these estimates are definitely only as good as the numbers that you plug in at the start. So we do recommend that you use some networking equipment, maybe routers that you have or network packet trace tools to monitor actual bandwidth that is used by a pilot set of users, and then extrapolate that out to the full set of users. That'll give you a better estimate.
So we've looked at capacity. Another thing that comes up a lot is latency. So how do we test for latency in terms of our connections back into Office 365?
Right, so we want to take a look at the network connectivity between users and Office 365. And let me show you a tool here for looking at the latency. We can take a look at the latency using PSPing. PSPing is a tool that measures the TCP connection to port 80. You can see 80 there on the parameters that I'm using. And it shows here that in my test, I'm an average of 8 milliseconds between my client and Office 365. The next thing I want to take a look at...
Hold on, what's the difference between PSPing and normal ping.exe before we...
Oh, well, normal ping is using the ICMP protocol.
Okay.
And we want to use the TCP protocol, connect to port 80 instead, because ICMP protocol is often blocked by networking equipment. It also may be routed or prioritized differently over the network.
I see. This is a great tool if you don't have it in your tool belt already. PSPing is free from sysinternal, so great tool to measure.
All right, so let's take a look at one more PSPing command connecting to our proxy server. And so this will tell me how long it takes for my client machine to connect to my company's perimeter network. And you can see an average there of just 5 milliseconds. And you can tell how long it takes from the perimeter network to Office 365 by subtraction, so we've got another 3 milliseconds. These are obviously fantastic numbers that we're getting here.
Yeah, when does it start getting troublesome? Because we've got very fast connectivity here from Redmond, but what about people out in the world that might have 200 or 300 millisecond delay times?
Right, so if we're 300 or 350 millisecond delays, then you'd want to take a look at where is that latency. Is it inside my network connecting to the perimeter, or is it outside my network where my ISPs and network operators are involved? And then you can narrow in and take more of a look at what equipment you've got and what's going on there.
Okay, so we've looked at things like capacity and also latency, but I know another thing is really throughput, or how fast the network's actually flowing. Do we have a tool to actually monitor that?
Yeah, absolutely. So another common issue that we find with flow control is TCP window scaling. And so where you're looking for issues, you want to take a look and see if you have this issue. This particularly impacts large files being transferred over long distances.
I've got a ferry analogy. So if I think about a car, it might have 1,500 bytes. The acknowledgement is actually the ferry that comes back, and with that I can get 40 cars on the ferry. Remember that number 40, it's important. Then that goes out and maybe another ferry comes back, and that acknowledgement can also take another 64K and another 40 cars. That's really tiny though, because when I've got scaling turned on, the ferry goes back out, now scaling's turned on, and I can actually do not 40, but 700,000 of these cars, because now I'm getting a gigabyte per ACK back for each trip that goes around. So these acknowledgements that come back and forth, I'm actually sending, instead of 64K, a gig per ACK.
Right, and this is really an artifact of the internet growing and the amount of bandwidth that we have growing, but the speed of light over fiber optic cable has not got any faster. And so over these long distances, we have these huge bandwidths. We really have to have larger buffers and have TCP window scaling turned on.
So what tool can I use to tell whether or not scaling is turned on?
Great, so we can look at that very specifically using a packet trace tool like Microsoft Network Monitor 3.4 that I have here. And here I have a capture of a TCP connection being initiated, and we've got the SYN packet and the ACK packet. And if I zoom in here, you can see that in the ACK packet from the TCP connection, it says here literally scale factor not supported. And this is indicating that either the client or the server that I'm connecting to, or more likely some piece of networking equipment in between, is blocking TCP window scaling from being able to be used. Okay. So what I'd like to see is if I go over to this other packet trace that I have, You can see here the same SYN and ACK packet, but in this case it says negotiated scale factor. It's showing me that the TCP window scaling was negotiated, and we can make use of those much larger buffer sizes that are available.
Right, so this is really great in terms of telling whether or not your networking infrastructure is up to date, but I know even beyond latency, capacity, throughput, there are other issues that we can solve for, things like DNS and how we've architected our network, right?
Yeah, so Microsoft has a global network with many internet egress points, and customers also often have networks between their offices all over the world with multiple internet egress points as well. So we want to optimize the connection between the user's PC, wherever they may be, to our server between those two networks.
Okay.
So if you think about an example where a user is in Singapore and they're connecting to maybe our APAC data centers, which are in Singapore and Hong Kong, you want to connect basically directly to those using the different internet connections that we have and that the customer has.
Right, because sometimes the DNS might be set up in, say, North America, and if those DNS calls go all the way back to North America, then back into Singapore, then it's going to cause a bit more delay, right?
Right, we do this GeoDNS thing, and if you look up our IP address for our servers in North America, we're going to give you servers that are in North America, and that means that poor user in Singapore is going to do the round trip all the way to North America, and then internally on our network, we'll have to connect back to their mailboxes in Singapore and Hong Kong anyway. So we want to try and avoid that situation.
Okay, so if I'm an Office 365 admin and really want to check for some of this stuff, what tools can I use there?
Great, so it's really easy to check for this problem. So here I am on my PC, and I've actually created a VPN into a Microsoft Office in Singapore to replicate that example that we talked about. So if I do a DNS lookup in Singapore, we can take a look. You can see it's connected me to a Singapore DNS server represented by SIN, and these IP addresses that it's showing me, they're actually in Singapore and Hong Kong. They're part of our Asia Pacific data centers for Office 365. So then what I want to do is, now that I've checked my office in Singapore, I'll disconnect from my VPN, and by disconnecting from the VPN, my machine is now it's in Redmond, Washington in the United States.
Okay.
So immediately I can do that DNS lookup again, and you can see that I'm connecting to a different DNS server. This is one that is in the United States, and I've got different IP addresses that have come back. And this DNS server is giving me server addresses back in the United States. If I saw the same IP addresses for the same servers, then I'd know that I potentially have this DNS problem where I'm looking them up in the wrong place.
Great, so we've seen between all of the things that we can do with capacity, latency, throughput, even looking at how we can isolate these DNS issues, there's a lot of stuff that we can do as an admin. Are there any more tips you have for troubleshooting?
So there's lots more of these common issues that you can check for. You should check out our blog, and please use the blog also to let us know if you have questions about network connectivity to Office 365.
Of course, you can stay up to date with all the news on Office at the Office blog and also on the Mechanics Wednesdays on Office Mechanics. Thanks for watching, and goodbye for now.